Hi everyone, today we will talk about the big O running time of the binary search algorithm. On the left side, it's an example code of the binary search algorithm, which will find the integer x in an integer array. Let's look at this code first. Interestingly, we were just focused on the recursive step because all the other steps are just constant time, right? So think about it. If there are n items in the original array, then in the second iterative, how many items will we go through? Think about it. I think that's an easy question, right? Because it's binary search, so we will cut the original array into two halves. So we will just go through half size of the original items in the second step, right? So we will get Tn is equal to C plus Tn over 2. This is because in the second step, we'll just go through half size of the original items, right? Let's call this formula 1. Then similarly, we will find Tn over 2 will be C plus Tn over 4, right? Let's call this formula 2. Then if we plug formula 2 into formula 1, we will get Tn is C plus C plus Tn over 4, right? And furthermore, if we continue to unfold this formula, we will get C plus C plus C plus Tn over 8, right? Then we will find the pattern here, which will become I times C plus Tn over 2 to the I, right? This is the pattern of this unfolding. Then at some point, this formula, the item of the array will diminish to 1, right? Which we will get n over 2 to the I will become 1, right? Here Tn is, let's call this formula 3. Okay, let's erase these things. So if n over 2 to the I is 1, we will get n is 2 to the I, right? Then if we take log on both sides, we will get log 2 n is log 2 to the I, which is I. Then we can find that I is equal to log 2 to n, right? Let's call this formula 4. Then if we plug formula 4 into formula 3, we will get Tn is log C times log 2 n plus Tn over 2 to the log 2n, right? Then it is C times log 2n plus Tn over n. This is just T1, right? And the purpose is to find the big O of this algorithm, right? So we can just ignore all the constants in this formula. T1 is also a constant. So finally, we will get that Tn will equal to log 2n. And that is the big O running time of the binary search algorithm. Thank you.